So now let us start with the building blocks of trigonometry. Let us see what they are and how we'll be using it throughout trigonometry. One thing that is very important, that in this video we'll be seeing the basic and the fundamental thing which makes the whole of trigonometry. There may be formulas, there may be different concepts, but everything starts from these trigonometric ratios. So what I will suggest is to please focus and pay attention on these ratios because they are very important. Okay. So let us start with a basic right angle triangle. Say I have a right angle triangle ABC, which is right angled at B. Fine. This is angle A, this is C. Let us call this theta. Now you know that sum of angles of a triangle is 180 degrees. This is already 90, and say this angle is phi. So I can say theta plus phi will be equal to 90 degrees. That is, theta and phi are complementary angles. Because you know that for complementary angles, if the sum of two angles is 90 degree, we say that both the angles are complementary. Well, we'll come to the relationship of complementary angles, how trigonometry relates them later on. As of now, we'll just be focusing on the basic definition of ratios. So there are 6 fundamental ratios, trigonometric ratios, that define the whole trigonometry. That are the basic 6 relations that relates the angles with the sides. So let us see what they are. The first one is sine theta. Sine theta is nothing but the ratio of the perpendicular AB, let us call this P, perpendicular, let us call this base B. So whatever we are talking now, we are talking with respect to this angle theta, right? This is our angle of concern that we are taking this angle as a reference, and then we are seeing the ratio. What are the ratios with respect to this angle, that will come on later. So with respect to theta, this AB is the perpendicular and this BC is the base and this H is the AC is the hypotenuse. Sin theta, which is also abbreviated as sin theta, sin theta, is the ratio of perpendicular by hypotenuse. And since all these 6 ratios that we are going to study are ratios, they don't have any units. Sin theta is P by H. Then we have cosine theta, which is abbreviated as cos theta. This is the ratio of base by hypotenuse. Third is tangent theta, which is abbreviated as tan theta. This is the ratio of perpendicular by base, which you can also interpret as ratio of sin theta and cos theta, because I know sin theta is P by H and cos theta is B by H, which will finally give me P by B. Fine. A reciprocal of sin theta is known as cosec theta. Cosec theta is 1 by sin theta. So this becomes the ratio between height and perpendicular. Cosec theta is the abbreviated form of cosecant theta. I'll write it here. Cosecant theta, which we say as cosec theta, which is nothing but the reciprocal of sin theta. So the ratio becomes H by P. Similarly, the reciprocal of cosine theta or cos theta is 1 by secant theta. That is 1 by, that is sec theta. Sorry, this will be secant theta, or which is abbreviated as sec theta, which is the nothing but inverse or reciprocal of cos theta. So this ratio becomes H by B. Lastly, we have tangent theta or tan theta. The reciprocal of tan theta is known as cotangent theta, which is abbreviated as cot theta. So this is nothing but the ratio of B by P, or you can write this as the ratio of cos theta by sin theta. So these are the 6 fundamental ratios that are used in trigonometry, and this is what makes the whole world of trigonometry. So I'll write it here again, once again, very clearly for you, and please make sure that you have a very clear idea about these 6 ratios, because these 6 ratios define trigonometry, right? So I have sin theta. Sin theta is perpendicular by hypotenuse. Cos theta is base by hypotenuse. Tan theta is perpendicular by base. Inverse or reciprocal of sin theta is cosec theta, which is h by p. Cos theta, reciprocal of cos theta is sec theta, this is h by b. And the reciprocal of tan theta is cot theta, which is b by p. These are the 6 ratios that are very, very important for trigonometry. And these are simple ratios, and you should be pretty clear what they mean, right? I mean, sin theta, you can never say that sin theta is b by h. Sin theta will always be p by h. Second most important thing that you need to focus is that these ratios are always defined with reference to an angle, right? For example, in this case, our reference angle was this angle theta. We defined all the 6 ratios with respect to sine theta, right? This theta. With respect to this theta, this is the perpendicular, this is the base, and this is the hypotenuse. So all these ratios are defined accordingly. Now, if I'll tell you, let us write the trigonometric ratios, all these 6 trigonometric ratios with respect to this angle phi. Okay? What I want to say is that let us consider a triangle, same right angle triangle, say A, B, C. This is right angled at B. Say this is X, this is Y, this is Z. Okay. Now say this is my angle phi. Okay. Now I want to write this all the 6 trigonometric ratios with respect to this angle. Before coming to that, tell me one thing very clearly. This is phi. Now with respect to this, can I say that X is my perpendicular and Y is the base? Just rotate the triangle anti-clockwise and check it out. When I was referring to this angle, the side adjacent to this was my base and the side opposite to this was my perpendicular, hypotenuse remaining the same. In the same way, if I am considering this angle phi, the adjacent side is my base and the side opposite to is my perpendicular, right? So now let me write the 6 ratios. If I want sine of phi, sine phi, I know that it is the ratio between perpendicular and hypotenuse. In this case, the perpendicular with respect to phi is x, so the ratio becomes x, hypotenuse remains the same, z. So the value of sine phi is nothing but the ratio of x by z. Similarly, cos of phi, base by hypotenuse, in this case the base is y, hypotenuse is z, so y by z. Tan phi, tan phi is nothing but sine phi by cos phi. So it is the ratio between perpendicular and base. This is my perpendicular, this is my base, so this becomes x by y. Cosec phi, now it is easy, reciprocal of sine phi, so z by x. Sec phi, reciprocal of cos phi, z by y. And cot phi, reciprocal of tan phi, y by x. So this is how we define trigonometric ratios, and this is how we always define trigonometric ratios. We never ever change the basic definition of these 6, right? These are fundamental and universal truth, you can say, and we always follow these ratio only, right? Second thing, and the most important thing, is that in case of these ratios, if I have a fixed angle theta, right, say the value of theta is 30 degrees for example, then whatever triangle it is, say I have this triangle, say this angle is 30 degrees and I have one more big triangle, both are similar, you can say, such that this angle is also 30 degrees. And now I know that I can divide this into two right angle triangles. Similarly, this can be divided into two right angle triangles. What I want to say is that if, say, this is h, say this length is, say, x, say this is h dash, and say this length is y. Now if suppose I need to write sine theta for the first triangle, which is equal to sine 30 degrees, sine 30, perpendicular by hypotenuse, say this hypotenuse is y, sorry, say this is, say, a, and this is b. Sine 30 is perpendicular by hypotenuse, so this becomes h by a. And in this case also, sine 30 is equal to h dash by b, perpendicular by hypotenuse. So always remember that if the angle is constant, this value will always remain constant. That is, for a fixed angle, the value of the trigonometric ratio always remains constant irrespective of the triangle. That is how the triangle increases. If suppose I knew h, a and b, then I can easily calculate h dash by equating both of them. Or if I know any three sides, I can calculate the fourth one based on the concept that the trigonometric value, this ratio remains the same. Whatever the triangle is, if the angle is fixed, the trigonometric ratios will remain same. Similarly, if I need to define, say, tan 45, tangent of 45 degrees, so whatever triangle is, if the angle is 45 degrees, it will always have a fixed value. What is that value? We'll see it later, but as of now, please make this concept pretty clear. So in the next set of videos, we'll see the values of the basic trigonometric ratios, and then we'll proceed further.